Okay guys, we are finally on the last section of 10, of Unit 10. This is going to be 10.7. We're going to actually be talking about two things. One of them is going to be called the arc length of a circle, and the last thing will be the area of a sector. So let me just grab my pen here and we shall begin. There we go. Is that the right one? Okay. So first of all, we're going to review a formula that you should already know, and that is the circumference of a circle. When we're talking about circumference, it's kind of the same thing as perimeter, how far around a circle. So if you have a circle and you know the radius, the circumference of the circle is 2 pi r. Okay, that is the formula. You could also think about it if you knew the diameter. So actually I'll just use the same circle. If I were to draw that, well, isn't 2r the same thing as the diameter? So you could also say circumference is equal to pi times diameter. So it just depends on what information you know. Do you know the diameter or do you know the radius? So we're going to do an example of finding the circumference here in a second. But before we do that, I wanted to talk about something called arc length. Now, back in the previous units, I want to say 10.2, 10.3, we talked about how do you find the measure of an arc, and of course we were talking about in degrees. We know there's 360 degrees in a circle, and so we were looking for, okay, well, how much of the circle is just this little part here if we were looking at an arc? And so what we're going to do now, though, is we're going to find what we call arc length. And arc length would be where you are finding, hey, my dog is chewing at the bottom of the table, where you would find the actual length of an arc in terms of pi, not in degrees. It's called radians. So let me give you the formula and then we'll look at a couple of examples. So as an example, let's say we have a circle. And I'll go ahead and call this arc AB, and we'll call our center here. So what we're looking for is the measure, not the measure, but we're looking for the length, I should say, of this arc right here, okay? That is the length of arc AB. So I'm going to actually give you two formulas to find the arc length. So the way we're going to name it is just AB with an arc over it. We're not going to be talking about degrees. I'll actually give you a different way to write it if we're looking at degrees. But to find the arc length, you're going to take the measure of the arc in degrees. You're going to divide that by 360, and then you're going to multiply that by the circumference of the circle. So in other words, it's going to be some fraction of the circle that you're going to be multiplying by the circumference. Now, I do want to give you another formula because sometimes you're not looking for just the arc length. Sometimes you might be looking for the radius, or you might be looking for the measure of the arc in degrees. So I'm going to give you another formula. It's actually the exact same formula, just written in a different way, that you can use if you are looking to find other pieces of information besides arc length. And the formula is you're going to take the measure of the arc in degrees, and that's what the M stands for. That means we're talking about degrees. Divide that by 360, and you're going to equal that to the length of the arc, and you're going to divide that by the circumference. So as an example, if I were looking for the circumference, I would use this formula because then I could fill everything else in and cross multiply and solve. If I were looking for the arc length, then I would come up here and use this formula. So these are the two formulas that we're going to be referring to as we go through the next few examples. Okay, so that was page 1. Page 2. So we're going to do our first example is just simply let's find the arc length. And so it says find the length of the arc AB. So recall, my formula to find the length of arc AB is the measure of the arc in degrees, divide that by 360, times that by the circumference of the circle. So the measure of the arc, notice on the problem, is 60 degrees. So we're going to say 60 over 360, and we're going to times that by, notice my radius is 7, so it's going to be 2 pi times 7, and that's going to give me the length of the arc. Okay, now we can just simplify this. Okay, so for instance, my zeros can cancel. 6 over 36 is 1 over 6. And I'm going to times that by 14 pi. And so that gives me 14 pi over 6. We can actually reduce that a little more. We could divide a 2 out of each of those, and you could have 7 pi over 3. And that would be the length of the arc in inches. If you wanted to calculate that out and get a decimal, you can. Honestly, I don't, you could leave it just like that, but let me go ahead and just calculate that. So on the phone, when you turn it on the side, there's your pi button. So you're just going to hit 7 pi, get your answer to that. Oops, I hit the wrong thing. Okay, so we're going to hit 7. I guess we have to hit times pi equals, and then we're going to divide that by 3. And that's going to give us really close to 7, about 7.33. So we would say approximately 7.3 inches, and that is the length of the arc. Okay. Now I have a few more examples here. Once again, we're looking for something on the circle, whether it be the length of the arc. In this case, we're looking for the circumference. Here we just want to know the radius. So remember, if you're looking for the length of the arc, you can just go ahead and use the formula that I had given you earlier, this one up here. Notice that 2r, if you look at this first problem here, they actually give you the d. So yes, this is the circumference of the circle, but remember, circumference, you could also use this formula here as well for circumference. So I'm probably going to do that. So the formula I'm going to use to find the length of AB is I'm going to take the measure, divide it by 360, and I'm going to times that by pi d, which is the same thing as circumference. Okay, so the measure in degrees is 118. Divide that by 360 times pi times my diameter is 20.28, and I'm going to go ahead and calculate that out. How I'm going to calculate that is I'm going to go ahead and multiply 118 times pi times 20.28, and then I'm just simply going to divide that by 360. If you want to reduce before you do all of that, that is fine. I'm just going to go ahead and punch it on in here. So I'm going to say 118 times pi times 20.28, and then I'm going to divide that by 360. And I get about 20.88. So that's going to be the length of AB. It's 20.88, and they don't give me any units on that, so it would just be units, I guess. They don't say feet or inches or anything like that. Okay, now if we look at this example, notice we're looking for the circumference. So remember, I gave you two formulas. If you're not looking for the arc length, you're looking for something else, my suggestion is use this bottom formula. Remember, the denominator over here is your circumference. So if I can fill in all of the pieces here, cross multiply, you can find your circumference that way. So I'm going to use that formula, which is the measure of the arc divided by 360 equals the length of the arc divided by 2 pi r. Now I'm probably just going to call that C, because I'm looking for this whole thing. If it's broken up like this, sometimes it seems like, oh, I need to keep going. No, you're just looking for this whole thing. So maybe instead of writing 2 pi r, I'm going to change my mind. I'm going to write just a big C there. Now let's go ahead and fill in the information. So the measure of the arc is 55 degrees. Remember, central angles are the same as the arcs. We're going to divide that by 360. The length of the arc, notice they tell us is 5.5. And we're going to divide that by C. And now we're going to cross, multiply, and solve. So we're going to multiply these two here, these two here. So we get 55C equals 360 times 5.5. And I get 1980. Hey, that's a good year. Divide both sides by 55. You guys probably weren't even a twinkle in your parents' eyes in 1980. And I get exactly 36. And they don't give us any units on that. So the circumference is 36. Okay. The last example, we're looking for the radius. So I'm going to go back to this formula that I had right here, except I am going to keep it as 2 pi r now because I'm looking for r. So I'm going to use the exact same formula. So the measure, it says of the indicated measure, it doesn't tell us, so I'm assuming we're finding the measure of, oh, we're looking for the radius. Okay, we're going to go ahead and use this. Now I've been using AB. This one is actually going to be LM, but it's the same thing. So I'm going to take the measure in degrees, which is 240, divide that by 360 equals the length of the arc, LM, which is 42.56. And I'm going to leave it as 2 pi r. I'm going to cross, multiply, and solve. So here, 240 times 2 is 480 pi r. And then here I need to calculate that, 360 times 42.56. So 360 times 42.56, 15,321.6. The entire, both sides, by 480 pi. Okay, so I'm going to go ahead and divide by 480 pi. So I already have the 15,000. Hold on a second. Stop. Oh my God, my dog grabs everything. Give me that. Give me. No. I'm sorry, guys. Okay. Sorry. Okay, so I should have locked him out of here. He's grabbing all my papers. So here I am at 15,321.6, and now I'm going to divide the whole thing by 480 pi. So I'm going to hit divide, parentheses, 480 times pi, close parentheses, then hit equals. And I got about 10.16, or maybe I can just say about 10.2. And that is going to be R. Okay, guys. All right. So that is called arc length. There's one more thing I wanted to talk about, and that is called the area. We've done the area of a circle before, I believe. And for some reason, the notes must be missing a slide because I don't have a place for us to write the formula for the area of a sector, which I will, we'll just have to do it on the side somewhere. But remember, the area of a circle is simply pi r squared. That's the area. So if I wanted to find the area of the shaded region, which is the entire circle, I would say the area equals pi times 3.8 squared, right? And then I would just calculate that out. If the directions say leave it in terms of pi, then you don't need to calculate the pi out. As an example, if I said 3.8 to the second power, I get 14.44 pi. That would be in terms of pi. If it says round to the nearest whatever decimal, then that means to go ahead and times it by pi, and that would give me 45.4 centimeters squared. So depending on the directions, are you going to leave it in terms of pi, or are you going to go ahead and calculate it out? Now notice that this one gives us the diameter. So remember, for area, you have to know the radius. Well, we know the radius is going to be 6. So the area is going to be pi times 6 squared, which is 36 pi. That would be in terms of pi. If I calculate that out, I get 113.1, and that would be in terms of feet squared. Okay, so there's the area of a circle. Now, I guess just somewhere on the side, maybe I can just do it over here, and then we can look at this example. Like I said, we must be missing a slide. I don't know, maybe your note packet has it, but for some reason mine doesn't. I couldn't find it, and that's a horrible circle, sorry. Okay, so what I'll do is I will draw my sector right here. So a sector is a piece of a circle, like kind of like a piece of a pie. And so one of the things that we're going to do is we're going to find the area of a sector. Now remember, a few minutes ago we found the length of an arc. Well, the formula is very, very similar. To find the area of a sector, I'm going to give you two formulas just like I did for the arc length. The first one, looking for the area of the sector, you're going to take, once again, the measure in degrees, divide that by 360. The difference is, instead of timesing it by circumference, you're going to times it by the area. Now, the other formula is going to be real similar to what I gave you before. You're going to take your measure of the arc in degrees, divide that by 360, and equal that to the area divided by the area. This is the area of the sector divided by this. So let's define what I use this A here. This capital A stands for area of the sector. Not to be confused with the point A. Okay, so that's what this means down here. It's the area of the sector. So as an example, if you're looking for the area of the sector, go ahead and use the top formula. If you're looking for anything else, you're going to use the bottom formula. So the area, we're told, is 59. Okay, we're told the area of the sector is 59. We're told the measure. What we want to find is the radius. So I'm going to use this bottom formula. I'm going to say 40 over 360 equals, I know the area is 59. I'm looking for the radius, pi r squared. And then we'll go ahead and cross multiply. So I would get 40 times pi r squared equals 59 times 360. Sorry guys, let me grab that. 59 times 360 equals 21,240. We're going to divide both sides by 40 pi. Okay, and that's going to give me r squared. Close parenthesis equals, I get about 169. Hey, now I know this is a decimal, but that's really, really close to a perfect square, isn't it? If I take the square root, I'm going to get r is approximately 13, and that would be in terms of inches. And there's my radius. I feel like I should do an example. Maybe I'll do one off the homework of just finding the area of a sector, so hang tight, I'll do an example of that. I think I just have one more page. The last example that I have is, now what we're going to do is, taking that information, we're going to find what we call the area of a shaded region. So to find the area of a shaded region, what you're going to do is you're going to find the area of the entire figure and you're going to subtract the area of the unshaded region. And that'll give you the leftover. So if I want the shaded, then I'm going to find the whole thing and subtract all the unshaded, and then that'll give me the area of the shaded region. So if I start with the area of the entire, take a look at this. It is a square. Remember, to find the area of a square, well, this was back in, gosh, first semester, you're going to take the length of the side and square it. So the area of the entire, and I'll work it out here under here, is going to be 18 squared, which I believe I know what that is, but I'm going to double check myself. Yeah, it is 24. Okay. Now the area of the unshaded region, notice each one is a circle. Well, in order to find the area of the circle, we have to know the radius. So if I were to draw both diameters here, remember this is 18, then that means that this diameter is 9, and so is this one, so is this one, so is this one. What is the radius then? The radius is half of 9, or 4.5. So the area of the circle is going to be pi times r squared, or pi times 4.5 squared times 4, because there's 4 circles, right? So it's going to be 4 times pi times 4.5 squared. And that's going to give me the area of the unshaded. There's 4 of them, and there's my area circle. So let's do that. So I have 4.5, I'll go ahead and do that, 4.5 to the second power. And I'm going to times that by pi. I'm going to get that answer, and then I'm going to times that by 4. And I get about 254.46, or I'll just make it 0.5. Now remember, how do I find the area of the shaded region? You're going to subtract these two. And so the area of the shaded is going to equal 324 minus 254.5, and I get about 69.5. And that is in terms of inches squared. And there's the area of your shaded region. Okay. Now, let me go to the homework, because that's the end of the notes. Let me go to the homework. Let me do one off of the homework for you, because I feel like we didn't do any area of the sectors. It's going to be on the second page of the homework. How about, I'll just do, how about number 9 as an example. It says find the area of the shaded region, and we're talking about this sector here. So remember the formula I gave you. There was 2 of them. This is the top one you would use because you're just looking for the area of the sector. We're not looking for anything else. So here I would say, okay, the measure of the arc, which is 60 degrees, divide that by 360, and I'm going to times that. Notice my radius is 10. It's going to be pi times 10 squared. 60 over 360 reduces to 1 over 6 times 100 pi. It doesn't tell us to leave it in terms of pi, and it doesn't tell us to calculate it out. I'm just going to go ahead and calculate it out and get a decimal for that. So it would be 100. Calculate it out as a decimal, you're going to get about 52.4. So I'm going to put that as my final answer is 52.4, and that's in terms of inches squared. And that would be the answer to number 9 on the homework. Okay, so let me tell you one more thing about the homework. So the worksheet, you do not have to do all of them. So let's see here. On the front page, on the front, you can just do the evens. Okay? 2, 4, 6, 8, 10, 12, all the way up to number 14. Okay, you can just do the evens. Okay? And how do we do problems like this? You're finding the area. You're going to have to break it up into figures you already know how to find the area for. Okay, so I see a rectangle and a half circle. On this page, I think this page, I want you to do the whole thing just for good practice. You can go ahead and take off 14 on that one. The rest of them should be pretty straightforward. No, okay, yeah, because I really want you to practice this. So yeah, okay, so you can take off 14 on the back. So the front page, evens only. On the back page, you can do all of them except skip 14. All right, guys, there's 10-7. I'll talk to you later.